So if you turn to page 391, it starts off with a review of solving linear equations. So I thought I would do this together with you, and I would reteach you the two main techniques that you learned in grade 10. The two main techniques that you learned in grade 10, one of them was substitution, and the other one was elimination. So the substitution technique that you learned, see if you remember this, this is where if you had two equations with two unknowns, if you could get one of the variables by itself, then you could substitute it into the other equation. So we have our equations numbered 1 and 2. Can you see in equation 1, the y is already by itself? So then you could go to equation 2, rewrite it, 2x plus 3, but instead of writing y, we would write and substitute in 4x minus 4. Now we just have one equation with one variable. So the algebra is back to grade 9 algebra. Can you put your like terms together? I'll distribute this 3. I'll put my x's together, so I get 14x. I'll add 12 to both sides. It'll give me 7. Divide both sides by 14. 7 over 14 is 1/2. And then, once you have one of the values, you could plug that 1/2 into either equation. So for example, I go to equation 1 because it looks simpler. I plug in the 1/2. Half of 4 is 2, minus 4 is negative 2. And our solution to this one is 1/2 negative 2. So what we did yesterday is we graphed both of the lines and found out where those two lines crossed on our graph. Today, we're looking at how to do that with algebra. Because sometimes drawing a graph is tedious, and sometimes when you draw the graphs, they don't cross at a nice point. Right? In this one in particular, the x value is a fraction. So you might be like, I can't tell exactly where these two lines cross. So the algebra method gives us a way to find out for sure where they intersect. Do you remember the substitution method when you see this again? Like, I remember taking that in grade 10. Okay? The elimination method. The elimination method is where you take both the equations, add them together so that something goes away. What you often have to do is you have to multiply the equations so that the coefficient of one of your variables is the same, but one is positive and one is negative. So what I'm going to do with my equation 1 and equation 2 here is I'm going to choose to eliminate the x's. Right now, I have a 3x and a 2x. If I multiplied equation 1 by 2 and equation 2 by negative 3, if I multiplied everything in equation 1 by 2, do you see that the x would become 6x? And if I multiplied everything in equation 2 by negative 3, do you see the x would become negative 6x? So I'm going to rewrite those. Multiply the first one by 2, 6x plus 4y equals 18. That's my equation 1. Equation 2 would be negative 6x minus 9y equals negative 33. That's my new equation 2. And you're allowed to do that because in equations, what you do to one side, you do to the other side. That would keep them equal. What the elimination technique says is if you can get the coefficients the same, but one positive and one negative, you can then add your two equations together, and 6x plus a negative 6x will be 0. 4 plus negative 9 would be negative 5y. 18 plus negative 13 would be negative 50. And that then divide both sides by negative 5, and you get your y value. To find your x value, choose an equation. And it doesn't matter which equation you choose. So if I choose equation 1, I would have 3x plus 2, and I plug in 3 for y, equals 9. Subtract 6 on both sides, divide by 3. X is 1, y is 3. So the second example, if we had graphed it, it probably would have worked out nicely. Because the point is nice, 1, 3, we probably would have found out that that was the solution. So these are the two techniques that you learned in grade 10, substitution and elimination. And we need to apply those now to grade 11. The difference in grade 11 is sometimes you'll have a parabola and a parabola, or a line and a parabola. In grade 10, you just had 2 lines. And 2 lines, what we drew yesterday, they could intersect once, have one solution. It's possible that they could have been parallel and have no solutions, or it's possible that they were exactly the same line and have an infinite amount of solutions. So what does it look like with parabolas? Well, you might have something like this. Y equals x squared and y equals x plus 2. You have to make a decision if you want to use substitution or elimination. Okay? Generally, over the big scheme of things, students tend to go more towards substitution. Okay? So in this case, can you get a variable by itself? Yes. Y is already by itself in both of the equations. So using substitution, I can rewrite equation 2 by putting in x squared from equation 1. And now we have an equation with just x. How do you solve an x squared equation? Well, that's our chapter 3, right? We make it equal to 0, and then we learn 3 techniques, but the 2 main techniques that we have moving forward are factoring or the quadratic formula. So in this case, first of all, before I can use either of those, I need to make one side equal to 0. So I'll move the x over and move the 2 over. Does this one look like it can be factored? Okay, probably. Good chance. So let's try it. Would be x and x. 2 things to give you 2 would be 2 and 1. I need a negative x, so negative 2x plus 1x. Sure enough, it factors very nicely. And from here, you get 2 values of x. So that means there's going to be 2 solutions to this question, which kind of makes sense. Graphically, this is one that's really easy to get a picture in our head graphically. And you see that the parabola, equation 1, that's just your regular parabola. And can you see that the line, equation 2 in green, well, that would have a y-intercept of 2, a slope of 1. It looks like it should intersect twice. It looks like we should get 2 solutions. Well, we've got 2 x values. Next, we just need to plug them in. So I could plug in 2 into mental math-wise, I think you could go right away to the solution. I could plug in 2 into equation 2. What would y be? Y would be 4. I could plug in -1 into equation 2. -1 plus 2. -1, 1. And those match up with this point and this point on our graph. So when you have a line and a quadratic equation, you could have 0 solutions, you could have 1 solution, and you could have 2 solutions. And we looked at this yesterday already. So if we do example 1, did I go too fast through the last one? Did everybody get this all written down? Yes? We want to solve this system of equations. Then you get to choose if you want to do substitution or elimination. A little bit of thinking will tell you that substitution would be better. We've already got y by itself in equation 1. So that means I can rewrite equation 2, but instead of writing y, I could substitute in 1/3 x squared minus 3. Do you see that it's an x squared equation? It's a quadratic equation. So if I combine my like terms and make one side equal to 0, I would have -1/3 x squared, right, plus x, and minus 3. If I add the 3 from the other side, that'll get 0. Now, how do we solve a quadratic equation? We either factor or the quadratic formula. Can you see that this one is easy to factor? There is a common factor in both of them. So we could take out that x, leaving us with 1/3 x plus 1 equals 0. After factoring, it's pretty obvious that x could be 0 from this one. This one's a little harder to solve. What value of x would make this bracket equal to 0? Can you see it? Can you do some mental math? Figure out what x value would make this whole thing equal to 0? Right? Minus 3. Okay? Now, sometimes in an equation like this, if you have fractions, it is an equation. You can get rid of the fractions early if you want. So I'm going to show you that if this was hard for you, the mental math of the 1/3 x plus 1, you might have chosen right away to say, I don't want to deal with the fraction. Whether I'm working with the quadratic formula or factoring, I don't like the fraction there. What could you do to get rid of that 3? You could multiply by 3. Now, if I multiplied this whole equation by 3, then the 1/3 would become x squared, the plus x would become plus 3x, and the 0 when you multiply by 3 would stay 0. So the blue equation is the same as the black equation. I just multiplied by 3. Maybe I'll put a little multiply by 3 right above that OR button to remind you that that's what we did. The factoring would be the same. You still have a common factor of x. You'd still split it up and get x is 0. Is this one easier for you to see that x is equal to negative 3? So mathematically, you always have some options, and as you get into more complicated math, the more math that you've learned, the more options you have at different times, which can make math a little complicated, because some options you choose might be more difficult than other options. But now that you have what x is, you just need to plug in the value and figure out y. I'm going to, looking at those two equations, I think it's easier to plug into equation 2. Can you see that equation 2 you could rearrange by subtracting x on both sides? So you would get negative x minus 3. And if I take that, one solution is if you plug in 0. Scroll up just a bit so you can see the negative x minus 3. If you plug in 0, you would get negative 3. The other solution is when you plug in negative 3. If you plug in negative 3 for x, negative 3 would be positive 3, minus 3 would be 0. So these are the two solutions to this question. I'd like you to try questions 3 and 5 right now.